So let's start our next section, section 2.2. We're going to talk about modular arithmetic. So let's start by remembering that we talked about this set last week. We talked about this set Zn, which is the set of congruence classes, or we use the phrase equivalence classes, modulo n. So for example, right, Z4, what are the equivalence classes in Z4? The equivalence class of 0, equivalence class of 1, equivalence class of 2, and the equivalence class of 3. So make sure to remember that these elements right here, these actually represent sets. So recall that these are infinite sets. And what they do is basically break up the integers into sets, these 4 sets, and it groups it based on the remainder when you divide by 4. Okay, so remember we talked about Zn. So now remember that Zn is really based off of the integers. And so what do we have when we talk about integers? In terms of operations, we have addition and we have multiplication. So we can ask, what about Zn? Does it have any operations? So we can define addition in the following way. We can say that the sum of the classes, if I take the equivalence class A and the equivalence class B, is the congruence class. Well, these are integers, so what I could do is add the integers, A plus B, and then write down the congruence class of that number. So what I'm saying is that, and we're going to use a special kind of plus because this is not just adding integers together. This is how we add congruence classes. It's A plus B is defined to be A plus B, the congruence class there. All right, so that's how we're going to define the sum of these congruence classes. So let's look at an example. Let's go with Z4. In Z4, let's add the congruence class 1 plus the congruence class 2. So we get the congruence class 1 plus 2, or in other words, the congruence class 3. Let's add 2 more together. Instead, let's add 1 and 3 together. So you combine them into the congruence class 1 plus 3, which you get 4. But this isn't one of the elements we listed in Z4, so you're going to have to think, what's my remainder when I divide 4 by 4? The remainder is 0. So sometimes you're going to need to simplify and reduce down so that you get one of your elements from Z4, either the equivalence class of 0, equivalence class 1, 2, or 3. Okay? We can also define a product in a similar way. So in Zn, we can say the product of the classes A and B is the congruence class containing, again, you can take those two integers A and B and we can multiply them and look at the congruence class of that number. So, i.e., we're going to again use a special symbol here because it's not just multiplication of integers, we're defining a new multiplication. So A dot B, circle dot B, it's the equivalence class A times B. So let's look at an example here of how we define this product. Again, let's stick with Z4 for now. So in Z4, if I take the equivalence class of 1 times the equivalence class of 3, you get the equivalence class of 1 times 3, or just the equivalence class 3. Let's look at another example. So if we take the equivalence class of 2 times the equivalence class of 3, this would be 2 times 3. The equivalence class of 6. Again, this is not one of the elements we listed out at the beginning. So what we need to do is we need to rewrite this equivalence class. And to do that, think about what your remainder is. When you divide 6 by 4, the remainder is 2. So here you have the equivalence class of 2. So again, sometimes you're going to need to reduce and simplify there when you do your operation.